Yep. No. Maybe. Um, I believe it will be -2 sine x.
Would it be -2? Oh, okay. And then 3 over x is ln 3x or 3 ln x? One of the
3 ln x.
3 ln x. And then root x is 2/3 x to the power of 3 over 2.
And technically this is magnitude of x. And that is minus, what was it, 2 over 3?
Yeah, x to the power of 3 over 2.
Over 2. Let's see. It's positive 2 sine x. Why is that? Let me look at this. Oh, because it's integrating. That's why. 2 sine x
Okay.
plus 2 minus 8. Yep. So for differentiation, it would be negative. Integration is going the other way.
Okay.
Okay, and B.
Um,
And I suppose we should have plus C.
how is product rule, not product, quotient rule a thing in integration?
Yes. However, make your life easy. Cos x over sine x sine x. What can you do to make that simpler?
Oh, 1 over tan x sine x.
And what is 1 over tan x?
Mm, I forgot the name.
Cot x?
Oh, hot, yeah.
Cotan?
Yeah.
What is 1 over sine x?
Um, cosec.
So that is another way of writing that. So now we have to find the integral.
We get given those, I think.
We sure do.
So formula book. Um, it doesn't say it in here. It should. Why is it not in here? I swear we get given them, but I can't find them here.
You're looking at them. I just copied and pasted them here.
But they should be in our booklet, in the formula booklet, but it's not there. It's only the differentiation.
Next page has integration. Or you could always use the
Big ones.
differentiation in reverse.
No, but it doesn't give you like what cosec is and stuff.
Okay, I know they give them to you on the integration page.
I don't know. This one doesn't have. So cot x. How do you integrate cot?
Integral of cot x cosec x. Can you find something like that there?
Would it be minus cosec x?
Yeah, that's the same as cosec x cot x. So that's minus cosec x.
And then 2e to the x is just 2e to the x again when you integrate it.
Yeah. The derivative of 2e to the x is 2e to the x, and so the integral is also 2e to the x.
Yeah.
Plus c. Yes, minus cosec x minus 2e to the x plus c. Any questions about those?
I just find it like difficult.
Yeah, so far so good. How do we do this?
So 2x plus 1 and over x. Oh, this is ln.
Mm-hmm.
Ln of fx plus c. It's like the reciprocal of ln or something.
Yeah, don't overthink it. I mean, we did part A here, and you got 3 ln magnitude of x, so when x is the denominator.
So it's ln 2x plus 1?
You're overthinking it. Integrate. And then just make your answer equal to ln 12.
I don't get it.
Integrate. That doesn't exist. Integrate.
How do I integrate that?
So this one comes up quite common as well. Let's see. What is 2 over 7 plus 3 over 7?
5 over 7.
So you're a smart girl. You know that's 5 over 7. I'm not smart. I need to do that. And if you can do it, you can undo it. Go on. You've put it together.
2 plus 1 over x. So 2 plus ln x.
Yeah. So 3a 2 plus 1 over x. And so that is 2x plus ln magnitude x. And we had 3a and a.
So you'd have 6a plus ln 3a minus 2a plus ln a. So 4a plus ln 3a plus ln a. How does that equal ln 12?
Make it equal to ln 12 and then solve it. Solve for a.
Oh. Is ln 3a plus ln a ln 4a or not?
What is it? Ln 3a plus ln a?
Yeah.
Log rules.
But no, it's divided, so it would be ln 3.
Hold on. Is it because it's minus?
Oh, it's plus, it's multiplied.
And so, go on.
So 4a plus ln 3a squared.
Yeah.
I'm not sure how to solve it.
Okay. Let me just see if my wacky method works. Ln 12. Probably won't. I have a theory as to why it won't. So it gave me a decimal. I might have to use a different calculator. What did you get?
So I got the integral as 4a plus ln 3a squared. But I'm not sure if that's right.
3a squared. And that's equal to ln 12?
Oh, wait. I think I might have done it wrong. And it should be minus ln a. Yeah. So that would give you 4a plus ln 3 is equal to ln 12. Okay, that makes sense. I can do it now. I got a is equal to ln 1. Is that right?
What is ln 1?
0.
Seems weird. I was expecting to see ln 3a minus ln a.
Yeah, but that just gives you ln 3.
Yep, that's grand. So did you get, what was it, 6a?
4a plus ln 3 equals ln 12.
So 4a plus ln 3 is equal to ln 12.
Mm-hmm.
And what was next?
I did ln 12 minus ln 3 divided by 4.
And so, what was ln 12 minus ln 3?
Wouldn't that just be ln 4?
Yeah.
Yeah, so 4a is ln 4 and a is ln 1.
No. That would only be true if you subtracted ln 4 from both sides, because then it would be ln 4 over 4, which would be 1.
Divide ln 4 by 4.
Yeah, so
I got 0.3466.
and let me go back to my thing. Is it this one?
Yeah, I don't know what the exact value would be. It would just be ln 4 over 4.
Yeah, and I'll write it as, let's say, a quarter ln 4, just so we know that this is the number that's not interfering with it, and that is there. Let's see. Ba-ba-da-ba. A quarter ln 4. Great. Neither calculator. Let me just. You've given me an idea. 1 second. Any questions with that one?
Not really, but
So,
it was hard.
yeah, there's no. Yeah, it doesn't. Okay. Very similar question. Let's try it.
So when you integrate that, you would have 3x minus ln x. Yeah. Yes.
Yep.
And then 2a. Then you would get 6a minus ln 2 minus 3a minus ln a.
Minus.
Plus. Oh, I write it in brackets, so
Okay.
that's right. So will that give you ln half plus ln half? Oh, and then you have to do 3a plus ln half is equal to 6 plus ln half, so a is equal to 2.
Equal to. A is equal to 2. Oh, yeah. 6 plus ln a half, so even just by inspection. Great. A is equal to 2. And so this one actually did work in the calculator. I think, so these ones, when it's just a number like 2, you can, the calculator will work. For questions like this one, they thwart you by making it a ln or log, and so you have to do it, but you can use the calculator to verify your answer. Any questions there? Let us see these. I think the top one is worth doing.
So when you integrate that, you would have, well, e to the x integrated is just e to the x again. And then e to the minus x would be minus e to the minus x. So then when you substitute ln A, you would have A minus A. Would you have A minus A?
That's going to be A.
Oh, A plus A, sorry. Minus 0. Wait, no. Yes, no. Minus 1. And then minus 1. I got 2A plus, wait, 2A minus 1 minus 1. I got 2A minus 2. And then 2A minus 2 is equal to 48 over 7. So A is 31 over 7.
Looks good. 7. No, we went wrong somewhere.
That's, oh.
Yes, we're doing too much in our heads. Let's see. I think this integral looks good.
It's next step.
Another way of writing that would be minus 1 over e to the plus x. And so this one, e to the ln a, is a minus 1 over a. Yeah, that's the difference. So that is a to the minus 1. Yeah. A minus 1 over a minus 1. I think everything else is the same.
Minus 1. So a minus 1 over a minus 1. The 1's just cancel out because you have minus 1 and then plus 1.
Let's see. So we're subbing in what is minus 1 over e to the 0?
E to the 0. Why would it be 0?
Ln 1.
Oh, ln 1 is 0. Yeah, so e to the x is 1. So you just have 1 minus 1, but it's in brackets. So.
You're correct. That's minus minus.
So that would just cancel out. So you have a minus 1 over a is equal to 48 over 7.
That's it.
So you could do a squared minus 1, where a is equal to 48 over 7. So 7a squared minus 7 is equal to 48a. And then it's just a quadratic. I got a is equal to 7 or minus 1, 7. But it says a is positive. So a has to be 7.
That's it. Great. So I think just take your time with these. Oh wow, I did it right from the very start. Ln x, ln 1, the integral of it. Yeah, 7. Okay, any questions there?
No.
I think you'll be okay for this other one. It's pretty straight numbers.
I probably won't do it though.
Yeah, we can do it if you want.
You know how it's x1 plus x over x squared? Could you cancel out the x's?
Partially, yeah. What could you cancel?
X and like 1x of the x squared.
Yep.
Okay. 1 plus x over x is... Would that give you ln x plus 1 when you integrate?
Might be. Is that your final answer?
Oh, wait, no. Ln x plus x. Yeah.
Shouldn't have x. This is definite integration.
Yeah, I haven't substituted it yet.
Okay.
Then 9 plus 9. I got 5 plus 9 over 4.
Ln 9 over 4.
9 over 4, yeah.
Looks good. 5 plus ln 9 over 4. Great. Any questions about that? Let's just see.
These are pretty hard.
Okay, we can try these.
So if you integrate 3 to the x, it would just be 3 to the x.
3 e to the x?
Yeah. It would just be the same. And then 6e to the minus 2x would be minus 12e to the minus 2x.
You're thinking of differentiation. For integration, you would divide by minus 2.
Oh, right. I always get so confused. So minus 3e to the minus 2x. And then b and 2. So you would have... Okay. So 3e to the power of b minus... Wait, when it's e to the power... Wait, never mind. I don't know how to solve it.
You could do it by inspection. So I just brought the other two to the other side.
Oh, I did that as well.
So
Oh, so 2 and b is 2. That's it. Okay.
B is 2.
Would you have to write by inspection in the exam, or can you just write the answer?
No, I just wrote that for you.
Okay.
And this is what I'd be writing in the exam. Just put that question in. And use X instead of B, because I can't...
Yeah, you can't do b in the calculator.
But graphical calculator you can do B. Is this worth doing?
Yeah, probably. They're all worth doing because I don't literally do not know integration. So P over X would just be P ln X. And you integrate, I think.
Mm-hmm.
So then you would have P ln 9 minus P ln 3. So you could do P ln 9 over ln 3, which would give you P. I got P ln 3 is equal to ln 81. So P is equal to ln. P is equal to 4.
Yeah. So using your log rules, you can do that. Ln 3e.
Just
Sorry.
divide in the calculator.
Yeah. All good. P is 4. And you can use the graphical calculator to put this one in because that has different letters. Good. Are these worth doing?
So hard.
Yeah, the bottom one looks tricky. Let's try bottom one.
Which one?
I think this one.
Okay. Yeah, that looks really hard. Like really hard. I have no idea how to integrate this.
Expand the brackets first.
X squared x cot squared x minus 3e to the x squared x cos squared x minus x squared x. Okay, I expanded it.
Okay. Was there any matchup here?
The first term is sec squared x cot squared x. So no.
Let me see.
Well, sec squared x is tan x. And integrate. But you'd have to do like product rule.
Let me see. I'm just thinking. So that's the same as sec x cot x all squared. Maybe this will cancel in some way. Cot is cos over sine.
Yeah.
What is sec x the same as?
1 over cos. Oh, so cos would cancel, and then you'd be left with 1 over sine.
And so what is 1 over sine x?
Cosec.
So that is cosec squared x.
Which, when you integrate, gives you minus cot x. Minus to x. And then the next one is plus 3e to the x cot x, I think.
Which is, oh, when you expanded it, was it?
Yeah, when you expand, you get minus 3e to the x sec squared x cos squared x. Yeah. So since we already know that sec squared x cot squared x gives you minus cot x, and 3 to the x is still 3 to the x, so you'd have 3 to the x cot x.
You would have to use some kind of product rule for integration if that was the case.
Really?
Because you have two. Because you have two x's times each other.
Is that a thing? product rule.
Yep. However, you don't have to worry about that. Look more closely. What is sec squared x?
Oh, it's not cot. It's cos. I read it wrong. Yay. It's not cot. It's cos. So the cos x, cos squared x, and 1 over sec squared x would just cancel out. 1 over squared x. Sorry. So you just have 3e to the x. I cannot. And then the last one is just minus sec squared x, so minus tan x. So there is a product rule for integration, but we don't know it, basically.
I mean, you kind of do some of that stuff anyway, like substitution uses it a bit, little stuff. Let's see. So that one goes there.
It's just solving.
And that was minus 3b. And then minus sec squared.
It's just minus tan x.
That is minus tan x. Plus a. Oh, that's weird. Minus cot x. Minus tan x.
But it's definite. You wouldn't have plus c. It's a definite integral.
Oh, we've got more to do. Okay.
I don't want to do that. Do we have to put the limits in?
I think you get the idea.
Yeah, I know how to do putting the limits in and subtracting. So
yeah, and I think it would help to even, as you do it, like just put in tan pi over 3 and see if it gives you some easy number. Great. Any questions there?
No. I'm in radians. No, I'm in degrees. Tan. Oh, that's fine. Okay. It should be in radians.
And actually, you can see.
So that's why I'm like, why? Yeah, it's root 3.
Okay.
Tan pi.
And they didn't even bother. They just, left it like that. So that's fine.
I know.
Okay.
Given that you're constant. Fine. Yay.
Just be a second.
You integrate it, you get 2x plus 3 ln x.
Say it again, sorry?
2x plus 3 ln x when you integrate, I think. Do you have to actually write the modulus sign, or is it okay if you don't?
You'll probably be okay if you don't. It's it is the modulus though. Integration is an area. I'm just thinking maybe one day you'll get like a -2, and you'll try to do ln of -2.
I know it's modulus, but if I don't write it, it's okay, right?
Well, so long as
if you have a negative, you have to do modulus.
Yeah, so long as you remember that.
I'm pretty sure last week I tried in class because there was a negative. I'm pretty sure I tried putting in my calculator and it didn't work.
There you go. That's probably why.
Because I forgot that. No, our teacher's so bad.
Why is that?
Our maths teacher, she's terrible. She doesn't even know maths.
I think this stuff is pretty straightforward. This isn't even the hardest stuff.
Yeah.
Like Greg was doing further maths and stuff.
He does further. He doesn't do further maths. What?
Or he's doing, I don't know, some entrance exam or something.
He's probably doing STEP.
Maybe that's it.
Yeah. He's in my class, so he definitely doesn't do further maths.
Okay.
I got ln 6a plus ln 5 over 2 and I subtracted.
Okay. So what's A?
6a plus ln 5 over 2. is equal to ln 1000. So ln 1000. Oh. So what's 1000 divided by 6, 8? Okay, I got A is equal to 16 ln 400, which might be wrong. It looks really wrong.
Ln
Yep.
2. Let's see. So did you get this? 6a plus 3 ln 5 over 2?
It's because, you know, when you do 3 ln 5a minus 3 ln 2a,
Yeah.
I think I cancelled out the 3's, and I don't think you can do that.
No. So I was kind of concerned about this one. You could try putting it as like the power, but that won't really work either because of bidmas. You have to do the power before you do the dividing.
So you have to do ln 1000 divided by 3 ln 5 over 2. I don't know how to like solve it.
Okay, so we got to this point anyway. Not sure myself. Let's see. Some exact way. No. You would subtract that from both sides.
Yeah.
And so you would get... Oh, I have an idea. Well, we'll see. Yeah,
I think you're going to do something very nasty.
I do have an idea. Ln 1000 has 3 zeros.
Mm-hmm.
That is equal to ln 10 to the 3.
Yeah.
That is equal to 3 ln 10.
Mm-hmm.
And so you get 6a is equal to 3 ln 10 minus 3 ln 5 over 2.
That's really smart.
Thank you.
Okay. No. Okay, so then 6a is equal to 3. So 2a is equal to 10 divided by ln. 2a is equal to ln 4. So a is equal to half ln 4.
That's it. A half ln 4, and watch this. That is the same as ln 4 to the power of a half.
Yeah.
What's 4 to
It's
the power of
just
a half? Yeah.
Oh my god.
So that part isn't obvious and almost never happens that you get an exact answer. Sorry?
Ln is like a log. I always forget that ln is like a log, so you can use log rules. Like I always forget that.
Yeah, it's just short for log base e.
Yeah, I know what it is, but I just forget that it's a log.
Okay. Let's see. This one. So yeah, you'll see how I keep factorizing out the thing, and that's so you get just a log of something plus or minus a log of something else, and that way you're not going to go wrong with any powers or bidmas or anything. Any questions about that one?
No, but it was like hard.
Yeah, they did.
And confusing.
So what do you give yourself for those ones?
Like a half.
You're doing better than you think. Yeah, so I think that you need to do some of this. Any idea about
integration by substitution?
This is I would call it reverse chain rule, maybe. So you
don't know.
You did it a little bit. What is the integral of this?
In an exam, can you use integration by substitution even if it doesn't say you should?
Yes, unless it specifies. So if it says use integration by parts, then you have to do
Oh,
that.
yeah. Yeah, I know. Cos 2x plus 3. Okay, I'm not sure how to do it.
What if it was let a be equal to 2x plus 3? What if it was just the integral of cos a?
Sine A, you would have sine A.
So that would be sine a, and then you would swap back and it would be sine 2x plus 3. If this was differentiation, what is the derivative of 2x plus 3?
2.
And so if this was differentiation, you would times it by 2. It's integration,
Okay.
so you...
Divided by 2.
Yeah, and I'll just leave it as times a half sine.
Okay,
Yeah, and I
so
like...
you integrate, but then you divide by the
Yeah, so what's
difference.
kind of weird is that you're still finding the derivative even though you're integrating, but you just divide.
Yeah. So it's basically integration by substitution, but you don't substitute anything.
If you
I
want to
don't.
say that's integration by substitution, where you don't substitute anything, I'll let you. And I kind of skip this let step. It's easier to just do it in your head
Yeah.
in one go. That's just
So
to
that would
see.
be 4e 4x plus 1 divided by 4.
And so what was this one, sorry?
I got 4e to the power of 4x plus 1 divided by 4. It was over
And so what is 4 divided by 4?
1. You can cancel out. So
Um,
then you
that's
e
not...
to 4x plus 1.
It's not correct, though.
That's right.
The integral of this isn't 4e, it's just e to the 4x plus 1.
Is it? I thought you had to bring the power, the x, like the power of the x down.
Well, what you do at the end is then divide by 4.
Okay, so wait, I thought that when you have like e to the power of like a number and x, you have to have, yeah, you have to do something. Oh, that's the same thing. Okay. I get confused between differentiation and integration.
And if you do get confused, that's why I use the example of like if it was just e to the a, it would just be e to the a, and so you would just use that as a kind of guide. And how about this last one?
In one of my tests, I differentiate instead of integrating.
That's their problem right there. Okay, C.
6 squared 3x. Okay, so tan 3x. Is it tan 3x over 3?
Probably tan 3x, and I'll write as a third plus a 1/3 tan 3x plus c. That was 1/4, and this was a half sine. Yep, great. Any questions about those?
No.
Let's hold on before we make it trickier. Let's yeah, let's do this one.
I have no clue how you integrate that.
It's the same thing.
Oh, it's like, okay, I think I know. I got two bracket 2x plus 1 cubed over 3. So 2/3 2x plus 1 cubed.
So if this was like,
I didn't put in the a in the
okay,
one yet.
What is the integral of a squared?
2a.
You're doing derivative? Integral?
Oh, integral. A cubed over 3.
So it'll be 1/3 a cubed, and then that is actually 2x plus 1, and so what you have to do next?
Multiplied by 2.
You're thinking of
Multiply by half.
Yeah.
Ugh, why do I keep doing this to myself? So it would be 2x plus 1 cubed over 6. Why do I keep doing this?
That's all right. Yes, that's that's 1.
So you see,
And I think you're fine for the rest of that, am I right?
yeah,
Yeah, so then it's just straight
it's just
solving.
the integrating that's the issue.
Let me see. Okay, let's do top left.
Okay, 2x minus 6 cubed over 6.
And that is, yep. And then you just go from there. Now let me go back. How about A?
A. Why does it say f dash ax plus b?
It is the integral of f dash, which is just the f of x. So the integral of the derivative is just the function.
Yeah.
It's just to keep these notation simple.
Okay.
Just
So
ignore it.
1 over third, 1/3, 3x plus 2.
I would just ignore it. What is 1 over 3x plus 2 the same as?
Ln 3x plus 2.
Not the integral. What is 1 over 3x plus 2 the same as? Polynomial form.
Oh, 3x plus 2 to the minus 1.
Yeah. And just use that.
Oh, yeah. That's easier to integrate.
Oh, maybe it isn't.
Is it not?
Maybe we should have just done the ln thing. Yeah. What was the ln thing?
Isn't it just ln 3x plus 2?
So ln 3x plus 2. Don't forget function inside function.
What?
Derivative of this.
Oh, chain rule. Right. 1/3 ln 3x plus 2.
I believe so. 1/3 ln 3x plus 2. Let's see. B.
So that's ln 2. Wait, no. It's got a power, so. Two x plus 3 to the power of 5 over 10.
Yeah. Great. Any questions about those? Crushing it. Question right.
I'm not sure to. Oh wait, k is just a constant, so you would just have k ln 2x minus 1 multiplied by half.
And would you be okay for the rest of that?
Yeah, it's just solving, so probably
Yeah.
I might mistake.
And some of these, the calculator would work with the calculator. You wouldn't get an exact value, but
Yeah, you have to basically solve it by hand.
oh, let's try this top one.
That's so mean. Wait, it's a constant, so it's just ln kx.
Is it? Yes.
Yeah, it
but
is.
something's missing.
Why? Oh, multiplied by 1 over k.
Well done. And then,
Yeah, and then it solves.
and I just want to make sure on that one. 1 over k ln kx. 1
Yay. Oh,
okay, yeah. 1 over k ln. Why is there no?
I thought it should be ln kx.
That was my concern.
It's not.
Let me see. I believe, yes, this is my concern. If you had 1 over 2, like a half x, so that's the same as 1 over 2 times, times 1 over x.
Yeah.
And so your integral is going to be ln x, but this is just a coefficient. And so that's 1 over 2. And so it's to do with...
But you already put 1 over k in. Oh, it's 1 over k times 1 over x.
Yeah.
So you get 1 over k ln x.
Yeah.
Understood.
It's if it was x to the minus 1, that power would be connected only to the x because of bitmas. Let's try. Well, let me just see if I have a similar one to that one. Might not. No. Let's try this one.
Okay, so look at I got ex plus 2, the whole cubed, over 3e to the x.
Oh, I don't have the thing for that, but I'm reasonably confident there. Yeah. And then everything else goes from there. How about this top one?
That's really evil. I don't like integration.
Yeah, it's harder than differentiation because it's reverse.
I don't know how to integrate.
Integrate 1.
X.
Integral of sine.
Minus cos.
And so integral of minus sine.
Okay. Minus cos kx.
So that will be plus pi k cos x. Yep.
Wouldn't you have pi k cos x, not
Sorry, pi k cos kx.
pi k cos k? Why do you have to bring the k out as well?
Is that not what you said?
Yeah.
Yeah, derivative of that.
You have to do like the reciprocal, like if it's sine 2x, you have to do half sine 2x.
You're right. It should be that, shouldn't it?
And wouldn't the pi be pi x because it's a constant?
Coefficient.
Oh, okay.
And do I have a thing for that? So that is x plus, pi over k cos kx. Let's try this one.
Oh, that's just the one I wrote. Oh, no, it's not. So pi over 2 would just stay as pi over 2 because it's the coefficient. Pi over 2 k cos k, no, sine kx.
And what happens with this k?
Yeah, it should be pi over 2k.
It's not times k.
Huh?
Not times k.
What do you mean it's not times k?
Are you saying like that? Pi over 2k sine x?
No, pi over 2k.
Ah, yes. That's great. And that's definite integration. That's great. Let's see. Okay, integrating.
Yeah, I get it.
If
It's too difficult.
so, that's much more difficult than the one we did before. And then trig identities. Yeah, so we did a little bit of those. How was that for you, Moga?
Hard.
Good. Anything in particular you want to do next time?
Uh, um, let me just check something.
I can check your topic list as well.
Yeah, because I have a test next week, so I just want to- Um, have we done forces in motion already?
Have we done what, sorry?
Forces and motion.
Let's see, we might have.
Mm.
I doubt we did all of it though. Forces and friction.
Yes.
Forces and motion. So we didn't do in dimensions, connected particles, pulleys. We didn't do those.
I want to do this.
Okay. Forces and motion, second half. And I'll send you a good worksheet for this
Okay.
integration where it's like, they're not exam questions, but it's just purely the actual nuts and bolts of it. Any questions for me in general?
No,
All right.
thank you.
Well done, Amogha. You did great. I look forward to chatting again next week.
Bye.
Have a good week. Goodbye.
You too.
Thanks.